Hi guys, how are you doing?
Good morning.
Yes, good morning. I missed that in Mexico is 9 a.m. Am I correct?
Yeah, sorry, I forget.
Yes. It's very early. And okay, it's amazing because you wake up and come to the class. It's really right to the class. And in my case, here in Brazil, is noon now, and it's close to the lunch. I'm not. I don't know exactly which time you lunch in Mexico. Maybe mm, for example, in US, my lunch time is a little late. It's 1 p.m. Here in Brazil, the families already lunch more close to one. It's something like that. In Mexico, which is the time that you lunch?
It depends on each.
But you lunch. It's not like in the West, like because in the West, I bought some bad food and sit in my desk and continue to work and eat the food. But in Mexico, you already lunch or you just only because in the West you have a breakfast. You really it's like a lunch really in Brazil. And in during the lunchtime, you don't eat a lot. You just only some few vegetables or bad foods in a general way. In the Mexico, you really lunch, or it's like in West, you just only eat something, but the best the main food is the breakfast. How does you work in Mexico?
Pues es que depende de cada persona, profe.
Okay.
But normally we have big breakfast, I think.
Oh, okay, perfect. Okay. So I hope you enjoy the meeting sessions that we had. If your group, I'm not sure, I don't know if it's Monday or Tuesday, but it depends. I believe, I hope you enjoy that time. The next week we have the same type of meetings. And today is a little different than dynamics. It's a regular class. My idea is I will present two topics. The first one is a little big. The second one is very short. And the reason that the second one is short is because the Professor Yepes is working, and we work more. We use more focus ahead. But my idea is to use the two first class to explain about architecture and about what is smart objects, in particular how provide some ideas about smart objects and working with the IoT architecture. And the 30 and the 4 times, we use the time to realize the lab 2. In the lab 2 is one exercise that use Cisco Pack Tracer to implement a real IoT environment in using a smart home. Okay, and we use the two last sessions, the two last hours to realize this exercise. Also, I will provide some insights about the oral exam and the argumentative exam. Okay, at the end of this session today. Okay, so any questions you hear? No? Okay. To access this, the session that we will have today, go to the canvas. In the canvas is this class here, okay? Architecture and design the heads, the IoT, okay? And here, just want to revise, we have two materials. The first one is network foundation that we already discussed in the last sessions. Is the time that I showed the main architectures, the main topologies, concepts, and what is a network, the main device that you have in the network. And today, you study about IoT architecture, apply specific about the IoT architecture is more applied topic. So any question about the last session? Do you have any question about the last session?
No.
Okay, guys. Okay, today's sessions is the idea is to introduce the architecture types in IoT. You see the most common architecture is the 4 layers. And after this session, you are able to identify what is an architecture, why you do need one architecture, and which the different layers that you have in IoT architecture, and in the different concepts that you already, when you work in the IoT using cloud, for example, most of the time you need to recognize some terms, and you use the session today, you learn about these terms. So first, we make a little review about what is IoT. Okay, just to see if the point works. Yeah, it's working. Okay. When you think about IoT, IoT is a system. Okay, it's not only about the device, smart device. It's not only about the cloud. It's not about the protocols. Is a system that has 2 characteristics: advanced automations and analytic systems. Think that IoT has a different type of sensors like smartphones, wearables, home lights, personal computers, smart vehicles, and all of these devices produce a lot of information, a large amount of information, and the IoT system provides analytic systems. What it means? Join this different type of data, aggregate this data, and transform this data in information, okay, using analytics techniques, okay? The second characteristic that you have, again, you have a smart wearables, okay? You have smartwatch and others, and we connect a different type of device and provides advanced automation. For example, I don't know if you remember in the first session, if I didn't wrong, I show one example where you have wearables installed in the patient, okay? And during the translation of the patient to the hospital, you share a lot of information, and in the hospital, you automate a lot of procedures. You select the best place that the ambulance needs to go. You select the doctors, you reserve the medicines and others, okay? You automate a lot of decisions that you need, that before IoT or without IoT, you need to do use a human and manually, okay? So IoT, again, is an advanced automation analytics system, which deals with, okay, artificial intelligence, sensor networking, electronic cloud message, and others. Okay, okay. We use the artificial intelligence. You use sensing. Okay, for example, in a smartwatch, you have a different type of sensors, and you use networking to provide media or to provide space to share the information, electronic and cloud message. In particular, the cloud you use to be analytics processing and the more advanced automation. When you think about the IoT, again, you need to think about the connectivity, okay? Remember, connectivity refers to make connection between all things in IoT environment. For example, the smartwatch, the smartphone, the appliance, home appliance, and others that exist in the IoT environment, okay? And the connect is a very important feature that you have. For example, most of the time you use wireless connection in IoT. For example, you can use Wi-Fi, Bluetooth, RFID, and others to provide connectivity between these nodes. The second feature is analyzing. Okay, after you connect the device. Again, you produce a large amount of data, and it's important to analyze this data, aggregating it, fusing it, and generating information. Integration. Remember that in IoT you can have different types of device. For example, you can connect, for example, Android smartphone with an iPhone and with Arduino or other device. Okay, you connect Linux, Windows, and Mac in a common framework. Okay, and to be able to do this type of thing, you need two words. You need to integrate, and you need to interoperability the data. Artificial intelligence. Okay, remember. If you use, you have course about artificial intelligence in the ahead, okay? For now, it's only important to know, for example, if you don't use artificial intelligence, all of your operations is deterministic, okay? All of operations it's like you programming. For example, when you create a method in Java, C++, Python, or others, to find for example, a string in a database, it is a deterministic operation. You go line by line in the database to find this, to looking for and find this information. When you use artificial intelligence, but again, to find information in a very, very big data, okay, or in a very, very large amount of data, you need to spend the time that we spend to make this search is very big and complete unrealistic in the most of the application. And it's the reason, for example, to use artificial intelligence. Think about the Google. When you search a term in Google, the Google needs to looking for a very large database. Okay, not only a very large database, but a very large database using completely different structure of data. Okay, data structure. Okay, and to solve this problem, you use no deterministic approach. It throws artificial intelligence. Okay, again. You will have a course just only to explain about artificial intelligence, okay? And you need to have more background to do this course. You don't have exactly all of background now, okay? In our course, you will just only very pass in the superficial of artificial intelligence. You don't go a little deep, okay? Sensing, okay? Remember that the sensor device use IoT technology to detect and measure things in the environment. You can measure, for example, the temperature, the humidity, the position of the sensor, and others, okay? It's a very important that sensing is a very important feature. Without sensing, there is nothing to do with using IoT. And a very, very important feature is endpoint management. Remember that you have a network compounded by a large amount of device. Think about one airport, like I show in the Arabian, or think about one aircraft that is that has in your IoT environment a large amount of device, okay? Or a hospital or a smart city and others. There are a lot of examples. But in all of the examples, you have a large amount of endpoints or of device. And it's a good idea to have a way to manage all of these endpoints in a central point, okay? You do it to define, for example, security and to tuning the performance, okay? Any question to here?
No.
Okay. So the first question is, why do I need an IoT architecture? Things in any network, okay, or any system, you have different capacities, okay, that is provided by their elements. For example, if you think network use a client-server architecture, you have a group of nodes that is client and a group of nodes that provides service, okay? If you use the web service architecture, it's a little different, but you have the same idea. You have a group of nodes that provide services and others that is client of this service. In IoT, it's a little different, okay? Because you really have a lot of a large amount of group of device that only is client, but you have in the same way a large amount of, okay, it's a little different because you have a lot of device that is service. For example, when you have a smartphone, okay, for example, a smartwatch, sorry, the smartwatch in IoT environment provides information from, for example, your life science, for example. When you have, for example, a sensor, a smoke detector in your home, the smoke detector provides a service. Smoke detects when you have smoke in a specific room, okay? And the second, it's the first characteristic. Most of the architecture in the network, you have a few service providers and a lot of clients. In IoT, you have a large amount of service provider and a few clients. Another characteristic is the heterogeneity of device, but of the service. You can have, for example, in a smart house, you have a very large amount of different sensors that share information and then cooperate one to each other, okay? It makes that you need to have a way to connect or to assemble this system, okay? For example, you have a smartwatch, you have a smart meter, you have smart lights and others, and you need to have a way to connect everything put everything in the same environment and organize and discipline how this device will work together, okay? It's the reason that you need one architecture. The most famous or the most common architecture in IoT is the 4-stage IoT architecture, okay? What it is, you divide the IoT in 4 phases, okay? And you analyze the flow data and control data, okay? The data flow and the control flow, okay? In the first stage, you have only the sensor and actuator, sorry. And the first sensor is the first stage is the stage that you have the device, okay? That you sensing the environment and produce the information, okay? And in this, and it's important to say that each stage has your specific security, has your specific type of service, and has your specific function and wordings. In this layer here, in the stage 1, you're looking for you have a very, the device has, the device does not have a very powerful, okay? There is no, much of the time is monoprocess, you don't have no threads, okay? And the battery need the life of battery need to be long, okay? For example, think you have a IoT environment that measure the water. I remember some groups of you show, and in the second session when you present about make a workshop about the IoT, a group of students show a water IoT network. And this type of network, you install the device in a very restricted place, the place that you cannot go every time, okay? It's difficult to come or is very far, okay? And the bad idea, you cannot replace the battery for a long time. The battery life is long, okay? A year, 2 years, 10 years in some case, okay? It's avoid that you need to replace or to install some type of batteries in external batteries in the place, okay? And it's the one main characteristic in this stage. You use a very small device with does not have a very powerful processing capacity and has a very long battery life. Also, the other thing that's important in this environment is to define the channel, if you use wired or wireless. Except in industry, okay, in the old installer, in the old implementation of industry, that you have a lot of wired connections. Today, most of the connection is wireless, okay? In the next session, we study, again, we have some idea about the wireless technology that you can use in the IoT. So, you have the second stage. In the second stage, you have the internet gateways and data acquisition system. In this layer here, the things what is more important is you receive the data from the different sensors, okay? A lot of sensors, okay? You receive a lot of data from different sensors, and you need to aggregate. What is aggregate? It's different than fuse. Aggregate is things that you receive the same information from 3 different cameras, okay? You have one event, you receive the information about this event from different sensors, maybe 2 cameras and other sensor, I don't know, maybe it does not have, for example, a acoustic sensor. You receive cameras, video cameras, and acoustic information to detect if you have one object or other. The aggregation is you receive three data package about the same event. Okay, aggregate is you select the information from the different data package and create a new representation of this event that you use the information from the three different senses. However, you have now one information about this event. Okay, it's different than fuse, and the fusion is different. You already have aggregate data. Okay, for example, you have one data about the event 1, another data about the event 2, another data about the event 3, and you join these 3 data to generate a new information. Okay, you infer a new, you interpret this information, the 3 different information, and generate a second information. Okay, you conclude on something about the 3 others information. It's the fusion. It's a really different, the concept. Okay, just put here to remind. Aggregate. Oops. You join same event from different sensors. Okay, and fusion. You join, okay, not join, you compile. Yes, I believe it's better. You compile different, okay, you compile the same event from different sensors and generate a unique representation of the event. Okay, it is what is aggregation. I will change the color. Okay, it is aggregation. For the otherwise, fusion, you compile different events from different sensors and generate a new information. Okay, you generate, I changed the here, you infer a new information. Okay, did you understand the difference between the fusion? Oh my gosh, sorry. Here. Did you understand the difference between aggregation and fusion? Yes or no, guys? Yes?
Yes.
Okay, perfect. So, okay. So, okay, yes. So, there is, okay. And what this internet gateway and data acquisition does is aggregation. He gets the information from the different sensors, okay, and generates the unique representation of the event. Okay, for example, you have the event, thinks that one event is you detect one water situation using cameras, okay? You detect using the camera A, okay? I believe I can show it better. Give me a second. Okay, can you see my whiteboard? Yes or no?
No.
Oh, no, okay. Okay, now you see?
Yes.
Okay, perfect. Things in this situation, you have a guy, oh my gosh. Now my whiteboard is black, I believe. Okay, I share again. But yes, it's not working well. Okay. Okay, did you see my PowerPoint? Am I correct?
Yes.
Okay. I will change a little. I will create okay, I believe now you can see my PowerPoint. So think of this situation here. You have a guy here. I will try to paint this guy, okay? It's not a beautiful paint, but it's, I believe you can understand that it's a guy, okay? And you have three cameras, okay? The camera 1, the camera 2, and the camera 3, okay? I change here, okay? The camera 1, the camera 2, and the camera 3. The three cameras detect the same event. It's this guy, detect these guys, okay? The aggregation thinks that you have in some layer a gateway, okay, here that receive the data from the three cameras. You have received data from it, you receive data from this one, and receive data for the 31, okay? And the three guys, the three data is about the same event, okay, about this guy here. Okay, despite it's the same information, okay, it's the same event, we will have different information because depending the angle of the camera, you see more or less things, okay? What the aggregation will do is, after you receive the three information, okay, it's the event, but you have you receive 3 times, okay? I change, see if you can change the color. Yes, I can. Okay, receive the information from the camera, yellow camera, the blue camera, and the green camera. What the aggregation does is create a representation that compounds the all other information, okay? Not all of the other information, but the more significant information from the other sensor. You delete or you take off the redundancy and the no important information that you capture. It's the aggregation, okay? But it's the same information. Did you understand? Yeah. Okay. The fusion is a little different, but we don't use fusion in the now, okay? So, okay, return to this picture here. Okay. Where's my pointer? Where's my pointer? Okay, easy. Okay, this layer, where's my point? Yes, it's here. Okay, this layer here will do aggregation, make some measure, and generate control. For example, in this layer here, in this type of gateway, you can, for example, things that you measure information about the temperature of one system, for example, and you receive a temperature that is above one threshold. And when this gateway receives this information, it can send a command like, okay, turn off the machine. Okay, or you can do open the gates, something like that. This level in the stage 2, you can does this type of thing. In the stage 2, you are really connected with the domain of each device. Okay, you have information about, for example, the things that you have temperature, one sensor that measures the quality of water. You have intelligence here about the water quality. Okay, did you understand? In the layer 3, it's a little different. Why is my point? Yes, it's here. In the layer 3 is a little different. Okay, it's close to the device as the internet gateways. Okay, however, in this layer here, you have a more intelligent service. In this layer, for example, again, it's close to the device. It's not as close to the cloud. It's far to the cloud. For example, the edge is installed in your company, in your campus, okay? In the edge device, you have analytics. You receive information from the internet gateways and generate some intelligence. For example, you analyze, for example, you try to detect fraud detection, or not only fraud detection, anomalous detection, things that you have a data that you have using specific, most of the time is works in the specific threshold, but in one lot of time, you increase or decrease a lot the value. Maybe it's anomalies, okay? And this, in the edge device, you have this capability. Another thing is the pre-processing. The data from these layers here, most of the time use in some cases use old protocols, okay, that you don't use anymore, okay. In the edge layer, you can pre-process this data and translate to the, for example, MQTT and others IoT protocols that you can pass through the firewalls and others, okay. It's another thing that the edge does. One more thing that the edge does is things, for example, you have a date, okay, you have on one specific date, and this data you have, for example, in the first measure is 2, who is not working, is 2, the second measure is 2, the third measure is 2, the value is all the time is 2, okay. What the edge does, you send only the first one to the cloud. You didn't send out the data because you don't change the level of the measure, okay? If you don't change, you don't need to send to the cloud because remember, edge is close to your device. You have a very high speed with a good bandwidth. But when you send the data to the cloud, most of the time you don't have so powerful connections, okay? And in this case, if you don't have significant change in the measure, you don't send the update information to the cloud. You only send this data, for example, things now in the next layer, you change, okay? Now you have 3. Okay, you send this data to the cloud, okay? It's the edge layer. Finally, you have the data center and cloud. In the data center and cloud, you have different type of advanced service. Is the place that you install the machine learning techniques to generate, for example, the clustering, to find information, to aggregate information, big information, to generate diffusion, to generate intelligence, okay, is in the cloud, okay? And another thing is to acquire data, okay, to generate the backup is in the cloud. And the management of the device, you can have some level of managing that, but the big, to manage the big environment, you put the cloud. Okay, any questions until here, guys?
No, teacher.
What is important here is, again, you have stage 1, stage 2, stage 3, and stage 4. Okay, here you have the ad layers. Okay, and the important thing is the architecture defines the data flow. Okay, for example, sensors send data to internet gateways that send data to the edge, that send data to the cloud. It's the same the control flow. Cloud send control to the edge, that send control to the gateways and data acquisition, that send the controls commands to the sensor and the sense layer. Okay. So now we start to revise. I already talked about our layers here, okay? But now we'll talk layer by layer, a little more deep, okay? So the first one is the thinking sensor actuators. In the next, after the break, we'll study about the smart objects, okay? And the smart objects is these things that you call the things, okay? There is a difference between sensors and actuators and the things. Things are able to talk with other things or people. Sensors and actuators just only capture information and apply commands, okay? It's not able to talk, to communicate or interact with other things, okay? And it's the reason that you say that sensors and actuators is not a smart object, okay? Sensor actuator needs a smart object like a controller, microcontroller, a computer, and to control the sensor and actuators and to talk with the other things, okay? So, things sensors and actuators. Sensor actuators are devices that can emit, accept, and process data over the network, okay? Sensors and actuators is only receive information or send information, capture information from the device and send to the network, or receive commands from the network and apply in the device, okay? The sensor actuator may be connected to wires and wireless. However, today it's much more common to have wireless, okay? Don't use more. You have implementation using wireless, but it's a very, when you compare with the others environment, is the few cases. It's not enough. It's not a large number of cases. It contains a different type of sensors like a GPS, electromechanical gyroscope, RFID, and others. Okay, and the connection, the sensors with the IoT environment is using local area network and the passive area network. For example, local area network is a Wi-Fi, for example, and the passive one. Remember, the passive one is because it's very short range. Okay, for example, the Bluetooth. For example, a smartwatch. In some cases, the smartwatch can connect with a local area network like Wi-Fi, but preference it connects with your smartphone using personal area connection. The stage 2 is the gateways and data acquisition. Again, the stage gateways and data acquisition provide a bridge between different communication technologies. Remember, in this layer here, okay, in this layer here, because the legacy implementation, you have a large number of protocols that is not support to the internet protocols. For example, you have device that is not possible to the data from this device cross files or security appliance. Okay, you only can use the data locally. To be able to enable that this data from this device cross to the internet and come to the cloud, you need to have an IoT gateways, okay, or data acquisition. This guy here translate the data from these sensors, for example, the legacy data, and transform this data to the protocols that you can use in the cloud, okay? We will see some examples in the next class about it. Again, the gateways and data acquisition connect between sensor network and internet. It performs protocol translation, aggregates all data, local process, a large amount of service, but the most common is the protocol translation. For example, translate a legacy protocol that is not able to cross files to a protocol that you can cross files, and aggregates all data. It's much easier to do it because this protocol really talks the language of the device. Okay. The type of network is a local area network, for example, a local area using Wi-Fi or cabling, or in some case, wide area network. In some case, you have this device installed in the field, for example, in the smart city or the smart grid. You have this type of device at the end, close to the users, okay, far than the company, but it's the distance between one device to other is big, and you cannot use Wi-Fi because Wi-Fi has a very short range. You need to use the cell phone network like a GSM or 5G or LTE, for example. The next layer is the ad layers, okay, ad analytics. The ad has two main tasks: analyze and pre-process the data before transferring it to the cloud. What the ad will do is receive the data from the gateway, or if the device is use the new protocols, you receive the data directly from the device and analyze the data. For example, looking for example, to anomalies, okay? And the ad layer, if it detects anomalies, each device can send commands to make the network return to the normal situation. He can interfere in the device to the network can return to the normal situation, okay? Another thing that this guy does is the pre-process, okay? It can analyze the data and save local data, save parts of the data locally. And one important thing is if the sensor gate, the data read from the sensor gate is not changed, the ad layer does not send the data to the cloud. It's saved locally to be used in the future, maybe audit when you need to audit the data. However, you cannot transfer to the cloud because the links that you have between the device and that most of the time is a very high speed and with a big bandwidth connection. But between edge and the cloud, you have a not so big links or not so big bandwidth. You don't have a big bandwidth. Also, you don't have high speed most of the time. It's an example of one edge architecture. You have, this example is in the Azure, Microsoft Azure. You have the device here, and the device sends data, and in the edge, you analyze this data, okay? And after this analysis, you can send comments to the device, or you can send the data to the cloud. In the cloud, you have a more advanced service like machine learning, time series, insights, and others. And the cloud can send deploy configuration. For example, the cloud can send, for example, operating system update, and it come to the edge, and the edge transfer the command to the device. Finally, and we will make a break before entering the, we have on 2 slides and we will make a break. The edge analytics is located closer to the data source. In other words, the edge analytics is close to the device, okay? For example, if you will talk about the campus, Mexico City campus, you have an edge device there. If you talk about the, what's the name? Santa Fe campus, you have another edge device there, and send to the Monterey Technology cloud. Okay. Only the large chunks of data will need to power of the cloud to be processed are forward there. Okay. You don't transfer everything to the cloud. Only the data, the power data, the important information to the cloud. Also, the security, most of the time, Edge provides security device. For example, if you have a firewall, you put the firewall talks with the Edge, not directly to the device. Finally, you have the data center. Okay, the data center is a central point that you have the big application is in the cloud most of the time, or your private cloud or a third-party cloud, and you provide managed service. For example, you control the device. You have endpoint managed capabilities. For example, check the version of the firmware, send command to update firmware, turn on, turn off one device, change the configuration or the one device. Okay, it's the thing that you have in the cloud. The data center and cloud is the brain of the IoT. It's the place that you install all of artificial intelligence capabilities. Okay. Different than the edge, the data center or cloud system is designed to store, process, and analyze massive volumes of data. The edge is not capable to process a large amount of data. Okay, the correct place to process this type of thing is the cloud. Any question, guys?
No, teacher.
Okay. Now it's 9:57. We'll make a break and return 10:07. Okay? 10:08. Okay? See you soon, guys.